Hey there, I'm John Burney, and welcome back to Machine Health 101. Today, we're exploring another essential tool in the vibration analyst's toolbox, spectrum analysis. Let's dive in. So what is a vibration spectrum? In simple terms, it's a chart that converts raw vibration data from the time domain into the frequency domain, using an algorithm called a fast Fourier transform, or FFT. It might sound technical, but here's why it matters. When a machine develops a fault like unbalance, misalignment, or a bearing issue, it produces a vibration at a very specific frequency. Spectrum analysis helps you see these patterns, identify what type of defect is developing, and take action before it leads to a failure. To make this easier to understand, let's look at a familiar situation like a family party. Imagine you're standing in the middle of a room with everyone talking at once. At first, it just sounds like a jumble of noise, but if you focus, you'll start to pick out individual voices. Maybe your uncle's deep voice, your cousin's mid-range chatter, and a baby crying softly in the background. That's basically what spectrum analysis does with vibration data. It takes a noisy time domain signal, all the machine's vibrations jumbled together, and organizes them into the frequency domain. That way, you can see how much vibration energy or amplitude is present at each frequency. In this example, lower frequencies might represent slower, heavy machinery components like shaft imbalance in a fan. Mid-range frequencies might point to issues like misalignment, and high frequencies are often where early-stage bearing defects or gear damage show up, like the baby crying in the background. These signals might be quiet, but it's important to catch them as early as possible. Just like in that noisy room, without spectrum analysis, you might miss the quiet but critical noises hidden behind the louder ones. So while trend charts can show you that something is changing in the machine, it's the spectrum that tells you what's changing and why. For example, the trend chart might show that vibration is increasing, but it's the spectrum that reveals whether it's due to an imbalance, a misalignment, or something else entirely. Spectrum analysis is especially useful for pinpointing the type of fault, tracking the severity of the fault over time, and differentiating between mechanical, electrical, and operational issues. To interpret a vibration spectrum, analysts use tools like sidebands and harmonic cursors to compare key peaks, identify fault frequencies, and confirm their diagnosis. And just like with trend charts, it's important to review spectra under consistent operating conditions like speed and load. Because as a machine's speed changes, so do the forcing frequencies in the spectrum. For variable speed machines, tracking speed alongside vibration is the key to making apples-to-apples comparisons and avoiding false positives due to normal operating changes. In Petasense Aero, it's easy to analyze vibration spectra with tools like harmonic cursors, forcing frequency markers, and speed filters. With waterfall plots, you can view multiple vibration spectra in a 3D chart, which helps track how vibration at certain frequencies is evolving over time. You can even sync multiple sensors on the same machine to capture vibration measurements at the exact same time, making for more accurate diagnostics. So to recap, spectrum analysis is your go-to tool for diagnosing machine faults. It helps you answer the question, what's wrong with the machine and what should I do about it? When paired with trend charts and waveform analysis, spectrum analysis becomes a crucial part of any predictive maintenance strategy. Thanks for watching, and if you found this helpful, subscribe for more bite-sized videos on condition monitoring, vibration analysis, and best practices in asset reliability.